welcome class to today's lecture. I'm going to talk about Git and GitHub today, and I'm Chenlong Eric Liu. Feel free to call me Chenlong Eric. Um, huh, okay, so before we started, something about me. I joined RPI as a PhD student in 2021 fall. My advisor is Professor Zhang Wen. My primary research is on robotics and some control stuff. So what do we do with robots are primarily on the robotics arm and to do robot arm trajectory optimizations, which may be helpful in some um, manufacturing process that utilize robot arm as a motion systems. So for example, the project we did last year is called Convergent Manufacturing Project, which we utilize a lot of sensors in an industrial robot cell, which is a advanced kind of manufacturing that you can do manufacture but collecting data with all those sensors at the same time. So in this kind of scenario, ROS will be very handy because you need to utilize different sensor modules. There may be different components, there will be drivers, there will be algorithms here and there. So middleware like ROS or maybe from here on you may heard of R or some other kind of middleware will be very useful in this kind of project. Before I join RPI, I do other kind of robot research, primarily on mobile robot, like problem like SLAM, localization mapping, and path planning kind of stuff. So that's about me. But the thing is that all my projects that I have done use Git and GitHub. And almost everything I have heard of, I have used before are on Git or GitHub. So before started, have any one of you heard Git or GitHub before this class? Cool. And hands on if you use Git or GitHub. Oh, class dismissed. No, I'm kidding. But it's good. So if you haven't heard it before, I will go through very detailed, like really the first thing the common thing you will do with Git and GitHub if you already used them before, maybe it's a refreshment for you. Okay, so let's talk about version control. So Git and GitHub are used for version control. And before you have Git or GitHub, the version control may be looking like this. So imagine you have a final project for some course, and your teammates like, okay, that's done our final project, and kind of okay, and let's say, okay, we have our final project. And then some of you say, oh, maybe you have to add this and that, so you have final project 2. And then some other members say, okay, we maybe need to add this and that, so the final project 2.5. And then your supervisor comes in and say, oh, maybe you should change this to that and this to that, and then you have final project done. And then some other person is not satisfied with this, and you have final project done. And then final project ultimate done. Final project super ultimate done. So you might encounter this kind of scenario, which is not clever at all to manage your version control, which is where Git and GitHub come in. So let's talk about Git. So what is Git? So Git is basically a version control system, which is free and open source, which is one of the most important part of this tool. Everyone can use it, and it's open source. You can just download it very easily. And a thing about Git is a distributed version control system, which means that so in version control, in a scenario of version control, you might be collaborating with your teammates. There'll be several team members, or even only yourself. You might have several machines that are working on the same time. For example, your laptop and your robots. Distributing means that every machine that are working in this project has a full history of the whole project you have, the full history of the project files, the codes, and everything, and history. One thing about Git is that it's small and fast. It's very efficient, it's very easy to use. And almost everyone I know uses Git. Honestly, before I really start going on Google and preparing for this lecture, I don't really know other version control system because we've been using Git, everybody is using Git, and it's just very widespread. If you want more info, then you can click on it. I will share these lecture slides after this. And then later on, what's GitHub? So first things, don't mess up between Git and GitHub. They are pretty different. They are different stuff. So GitHub is a website and cloud-based service that hosts and checks Git. Well, basically, you can go to a browser and type in github.com. Then you can link to the GitHub. So which hosts the Git system on a website on our server system on server. You can log in and do every services they provided. You can access control. You can manage the access control. So for example, you may want only your team member and your supervisor has access to a repository, so your code, not other people. Or you may want everyone to access the code, so you can manage that. They can track bug, which is very nice and very fancy feature, especially after OpenAI after the ChatGPT blooming and everybody using those kind of those deep learning based text manipulating network to do everything. So they kind of utilize this technology to do bug tracking and also other stuff before ChatGPT. And continue integration. So imagine you have several people, you developing several functions at the same time. So Git is very simple, but GitHub has a nice graphic user interface that you can manage the integrations. You can open a pull request ticket. We will mention that afterwards. So basically, it really helps people to do continuous integrations and more stuff. One thing very nice about GitHub is that, as I say, they host it on their server, so it's going out worldwide. You can share your project with people on the other side of the world. You can share project with your supervisor, your teammate, the newcomers. You can share your homework to the lecturer or grader. So it's a very nice way to share things. So talking about share things, which means that there are also many great open source projects or software codes out there. Typically, people will put their code there. They might also put licenses, and there are different kind of licenses, but ultimately you can all utilize them in your project. Maybe, so say you're building a robot, you want some code doing SLAM, you want some code doing path planning, you want some code doing control. You can actually find every piece of things on GitHub because they're just too rich. There are just so many projects, so many open source tools over there. And not just about robot, there are people doing, I don't know, fluid dynamics and maybe doing something about CAD or improvement on some, I don't know, video game experiences. They're just everything. They're just everything. So the great thing is that you can just go, if you need some kind of tool, you can actually just click, you can do, for example, you want a path planning algorithm, you can do like path planning algorithm GitHub. The Google might just give you several options. So it's just a great rich treasures over there that you can just dig in and find useful tools over there. So please utilize them. And one thing about GitHub is that it was acquired by Microsoft 2018. That's why I mentioned ChatGPT. So they're kind of all under the umbrella of Microsoft. They can utilize tools here and there. So that's GitHub. Cool. And back to version control. So what is version control really means and how Git actually doing it? We can kind of give the overview by showing these three structures over here. So don't be too intimidated by this. I will go through them one by one. So first, when you are doing a project, you have a current working hat. So that working hat is the version or the code that you're manipulating with, the current working things that you're working with. Then in Git and GitHub structure, they have versions. So in this picture, you can see there are two lines under each dot. So first thing is that Git gave every version a kind of a code stuff. So there's a just random random code associated to each version. And besides those codes, when you publish or commit a version inside Git, you actually give them a commit messages, which are typically mean something. For example, you add a function to do this, or you fix a bug in something. So they might be they're just useful message that if you track the history, you can know what you're doing. So there are versions when you do version control, and branches. So there, of course, will be branches. So imagine you and your teammates are doing a project, and at some point you say, okay, we need some function to do. We need a function one, but your teammate don't want you to mess up the main code when you're developing stuff. So you can branch out a branch that just do specifically for that function development. And after everything is checked, after you make sure that code has nothing interfere with the main code, then you will do a merge. You merge the some develop function branches into your main code and checking everything's fine. So that's the whole idea of version control and how Git actually doing it. So everything okay? Am I going too fast? Oops. So okay, so now I'm going through the kind of the what typically what's the daily life of working with Git and GitHub. What's how we how we finally come to the tree like that. So initially you will create a repository or repo. So repository is a storage space that store everything about your project, the code, the history, the variation of your files, so that all those things will save in your repository. So you will create a repository, and you will have a first first committed version. So this is a current working head, and imagine you just create that. So you have an initial commit. Then you might add some description, and then you commit on the version. So voila, you have the second version. And then someone starting thinking, okay, we need to add some function one to our current project. And so that's where branches coming. So you're maybe you just branch out another branch and doing some function development. At the same time, you were developing the main code, maybe adding some text update or whatever you like. So you're working with the main branch, but some other people was adding some other machines or things were working on the main branch. And after a few versions later, the function is finally developed well. Everything is checked, and you also have some update on your main branch. There are several versions, and you say, okay, I think the first version of function one is ready. So you merge into the main branch, and continue and so on and so on. So perhaps the function one can start doing the development in version 2, and the main branch can keep on adding stuff and do whatever you want. So that's kind of the daily life happening with Git and GitHub and version control. So yeah. So what we're going through today, I will actually go through the whole process with all you guys to make sure you know how to do this, how you actually utilize Git and Git, how are the commands you have to do in Ubuntu. So we will create a repository on GitHub. We will commit a versions with these commands. We will create a branch. We will switch between branch. We will list out what the branches right now. We will merge a branch to another branch. We will see what happens. So think about like if two branches adding in a same file, what will be happening if they merge together? There will be some conflict. There will be conflict, and how GitHub might or might not solve it. Okay, so that's everything, and I want to start doing the demo right now. I need to stop sharing that, but I'm going to share my whole screen. Okay, cool. So the first step is to create a repo. So to create a repo, you go on GitHub. Sorry about that. You go on GitHub, you click new. Oh, actually, I'm going to create a repo with the same name, so I'm going to delete this one at this moment. And you will see GitHub is kind of very nice. So if you want to delete a repository, you can delete this, and I want to delete this, and he will tell you there will be bad thing happens, and you will understand that, and make sure that you're. So the GitHub will make sure that you really want to delete this. Man. Yes, he really want to share. I mean, once you delete that, everything's gone. And if you're really developing a really large project, you don't want to mess up with stuff. So okay, the first thing if you want to create a repository, just click new. Clicking your repository name, the descriptions. Do you want to go public or private? So if private, then only the people that you granted access will have access to this repository. Add README, yes. Typically, I will add a README. So README is a file that you will probably add in the project description, how you use the tool, how other development can contribute it to your project. So README is the kind of the introduction to your whole project, where you put all the introduction to your project to this file. Something more is the GitHub will ask you to if you want to add a git ignore. We will mention that afterwards, and also you can choose a license. I'll just choose whatever at this moment. So the different license have different. Well, I'm not like super professional in law, but they have different granted access, or if you want to commercialize this and that, what will be happening. So just choose whatever suited for your purpose, then create a repository. And voila, it is. So now you have a repository on GitHub. The next step is you want to clone it to your local machine. So it is on as we mentioned, it's on a server right now, and you want to clone it to your local machine. So what I'm doing is that I'm going to copy this HTTP and go into my virtual machines and go git clone. And it's cloning ready. So if I doing ls, so if you learn that you can show off your files indirectly, you can see there's a folder over here. The next step is I want to commit a new version. So there are two things I want to do. So first, check the file status. You can go to the folders and do git status. And it says that, okay, you're not on branch main. Stuff. So imagine I'm starting to do development. So what first thing I want to do is to modify the README files. Get it README, and I want to do just add some random stuff. Add descriptions. Cool. So first, I modify the README file. The second thing I want to do is to actually add a new file. That's called new file, a py actually. And I'm going to do this is a new file. Save. So in this folder, you can see first I modify this README file. Second, I create a new file called new file. And when you go to git status at this time, you'll see that the terminal tells you your branch is up to date. It's up to date because you didn't commit a new version. And change not stage for commit. So this is not staged yet. And this is on track new files. So in Git, you can see this visualization of Git, kind of how they do commit to the new version. So you first have to git add all the files to change in your working directory to a staging area, and then you will commit the new version. So I'm going to do that actually. First, I'm going to git add readme and git add new files. Enter. Git status. So you can now see that they are turning to green, which means that they are in staging area right now and waited to be committed. And you can do git commit, and then here's where I say. So now you do git commit -m and you add a meaningful description of your commit version messages. So I will do add. So what I do is I add some descriptions, and then so that's that. So let's do git status again. Now you see that when I type in git status, it tells me that my current branch is one commit ahead of that origin man. So what you should do, so now it's something like that. So your local machine is one version ahead of the remote machine. You have to do git push origin man. So click, and it will ask for your username and your password, but the password is not actually your password. You actually have to go here, developer settings and tokens. Don't worry about this. I have a tutorial. You can follow that. But you have to generate a token. So now GitHub has more sophisticated way to protect all your code. So you cannot just simply type in your password. You have to generate tokens. Okay, now this is a token. Copy paste. Voila. Okay. So now I'm pushing my current version. So now it's looking like, oh, sorry. Yeah, please. Okay, yeah, I'll post it. Actually, I'm going to show you right now. Okay, so you now push it to the to GitHub, and you will see now it's add description. So you actually have two commits, the initial commit and add descriptions. Okay, I'll let you try that if I assume everybody have the virtual machine on, and I'm going to share the tutorial guide and let you try that. And not going to I think maybe I will go through some other stuff before that you tried it. So what I wanted to do today also is to teach you how to do branching and to do merging. But consider time, I'm going to do you might stuck on it for a while, I guess. I want to share some do's and don'ts when you work with GitHub. So some do's and don'ts about GitHub is please do git pull before working. So make sure you have consistent version between every machines. Do commit as much as possible when you have a new feature or you just solve bug, then just do commit. Don't wait until the last time. Check, do git status. So do check while you're editing. Just don't add random stuff. Do write meaningful commit messages. Do push your work whenever you have a new version. So just push it and make sure everything is consistent. Be careful about merging and utilize branches. If we have time, we will talk about that. And don't git add large files into your repository. So large files, everything is more than 100 megabytes. Please don't add that to your GitHub. Otherwise, your repository will be very non-efficient when you work with that. So these are some do's and don'ts. Beside the command line, the Windows and Mac OS have GitHub Desktop. Something looks like this, which is great. It will shows you what you have changed, you have not changed, what you have deleted in a graphic user interface. So if you're working with Windows and Mac, you can use that, of course. So other thing I will not cover in this lecture is what if when you merge in and you have conflicted. So typically, if that happens, you have to go into the files and solve the auto merge files. What if you commit the version, you want to revert to the previous version? What if you want to ignore some files in the system? What if if there using other credential to access repo? So GitHub give you three types of credential you can use. So the HTTP is the tokens we just mentioned, SSH, GitHub CLI. So if you're interested, you can Google how to use different credentials to access your GitHub repo. There are tons of things about GitHub and Git and GitHub. If you want to know more, you can click on the link and you can do that. So we have some time. So I want you to really just do the first, try to create a repository and just add things, just make changes and try to add this and that, which will it is very crucial for your future project development and everything. So if you may, you can start trying that. And I'm going to share the tutorial with every comments that you need to all you guys. Okay. One thing I would like to mention is that if you're using the virtual machines that from Yabun, please do git config and global use git config global username and your name. Change the configurations of Git. Otherwise, you'll find some random guys is pushing things to your repository, which is because they save other configuration in their Git system. So now please turn on your virtual machines and try doing that. If you have a question, just let me know. Hmm. How many of you have wait, how many of you don't have virtual machine right now on your laptop? Oh, okay. Oh, okay. No, actually, never checked that. So if your virtual machine cannot access internet, but your laptop actually can, then go to player, go to manage, go to virtual machine setting. So the problem is that it has different network adapter setup. So instead of bridge, you might need NAT. Check OK to see if it works. If it doesn't, then reboot your virtual machine. If it's too fast, just raise your hand, let me know. Yes. Yes, so you don't necessarily have to create access GitHub in your virtual machine. You can actually access GitHub through your native host browser. So Safari or Google Chrome, Windows or Mac OS. So it doesn't, you don't have to access that. Same thing. That's okay. Yeah, you can. How many of you already create a repository? Oh, cool. We have progress. Um, anyone feeling frustrated? So how many have you do git add and git commit? You done? Yes. Oh, okay. Great question. Oh, let me just do it one more time. When you do git, uh, so when you do password, it will actually not showing anything. It's their protection mechanism. So just just copy paste the tokens. And if you want to paste in terminal, then you should do Control Shift V. So typically you do Control V, but it will not work in terminal. You have to do Control Shift V. So oh, that's good. Yeah. Modify or get it. Oh, sorry. Oh, So okay, how many of you commit something? Cool. Yes.
Right. So, so yeah. For in one copy, you can also. Pretty much all this.
You're not inside.
So.
Yeah, it's on. I think it. Oh, you haven't. Maybe you're so confused. First nation crazy. Oh. No, don't worry. When you pick down your career one.
So, where can I find those?
Oh, it's saying adding your or something. And develop it. You want? You want to do it? Kind of do that around it.
Yeah, it's kind of. So that student's trying to get those. So I'll give it about 5 more minutes or so, and then I'll go over some ROS stuff. So of course, if you're still having difficulties, right, so the great part is that when Derek asks how many people have done this, right, notice how many hands went up. There's probably a good chance there's somebody in your group that was able to successfully do it. So that gives you an additional resource besides us for trying to navigate through utilizing the campus. So, in a few minutes, we'll transition back.
On personal life. Is there are two of them? I use this one, but you can try it this one. Also, I probably takes too much, so maybe. Second. So. Where? Okay, so I'm going to end this. And I think it's great that you give me a lot of feedback that there's little detail I need to put into my tutorial. So I will update the tutorial, the overleaf, and you will see more stuff in that overleaf. Hopefully, we will solve most of your problem. But if you still have problems, it's just screenshot the terminals and ask me, post it in the webtext, and I will answer your questions. So thank you again.
All right, so we're going to transition a little bit, take a break from what we had there. All right, screen 2. You might have to open and stop. Nope, never mind. We're good. I think. So I'm going to take a little bit of a transition and talk again about some of the key things in ROS. Right, so there's lots of different ways that we can connect nodes. Right, so nodes are those key elements of code. Right, so it might be something like you have a node which its entire purpose is to, say, take data from a camera and transform that into an image that you can actually display. Right, so it's doing one key function, and once it does that function, right, we need some way to maybe talk to another piece of code, right? So maybe you have another node that's going to request an image, right? So it's going to send some kind of request to that node to let it know I want some information. Or it needs to be able to get the data, right? So once it has an image, assumably somebody's going to want that image, right? So it needs to be able to put it somewhere. And so there are different ways that we can do this communication. Probably the most basic is the idea of publishers and subscribers, which communicate through topics. Right? So typically the format is you have one publisher and multiple subscribers, right? So something like a camera node can publish an image, and maybe you have different image processing nodes which all subscribe to that same topic. Right? So if we look in the top right, so you have the publisher is going to take the data, which is in the form of a message, right? So the messages define how that is going to be structured, right? So are you providing integers? Are you providing strings? Things like that. That's what the message tells you. And it's going to publish that message to the topic, right? So the topic is like the pipeline that we can access. And then the subscribers can pull that message from that topic. Right? So one of the more basic ways that we can communicate between our nodes. Another thing that we can do is we can utilize services, right? So this is for something that maybe has a little bit of processing time. And the idea here is that you have what we call a server, and that server is running some kind of process. And then you have clients that can request the information from the server, right? So if we have a client node here, and this little gray circle here is the message that we send. And so we can send a request to the service. This request goes to the server and tells the server, hey, I want this information from you now. And so then the server can send this response back to the client that asked for it, right? So where the publisher subscriber type of method, the publisher is always pushing the information and the subscribers pull anytime that they want. Here we have the server is running and the client has to request when it wants the information. And another thing that we can do is actions. So these are good for things that take longer time to run. So maybe you have some kind of path planning algorithm. It takes a little bit of time to do that processing. And so you can have an action that is running. And the advantage of this over a service is that actions you can interrupt, right? So say you send an action request, you want, say, a robot to go to some position, and then you get some information which says, well, I can't go to that position, right? You might want to be able to interrupt that action. Services don't have an interruption, so that's the main difference between the two. And another thing is that the actions can also provide feedback, right? So what we would have in this case is you have your first node here is going to send a goal request to the node that's actually running the action. And then it's going to basically confirm that, yes, it knows that you sent some goal and it has that information. And so now you can actually say, all right, I want you to go ahead and do that. And so the node that's running the action is going to provide continuous feedback to that first node, right? So it's going to say, like, if you're telling the robot to go to a position, maybe the action server is going to give you the current location, right? So you can monitor how the robot is moving. And then once it actually either accomplishes that result or gets interrupted or has some kind of error fault, then it would send a response to let the first node know, I'm done doing what you requested me to do. Here is the status, right? So did we actually accomplish the goal that you set out? What errors did we have? Right, so different ways that these nodes can communicate, and it really depends on what it is that you're trying to do. Right? So if you're utilizing something, say like just a sensor connection, you're probably going to use just the publisher subscriber topics. Right? If you're doing something like path planning, which takes more time, you might use something like instruction. Right? So different ways that we can communicate. And then there's also things called parameters, right? So we can provide almost like settings for a node. So it's possible that we can define, maybe for a camera node, maybe we have a parameter that tells it, do we want RGB or a grayscale image, for example, right? So something that might affect how the node performs. And so when we're working with these ROS nodes, we're going to be utilizing the terminal a lot, right? So we can start nodes, we can monitor nodes, get information about these nodes, and also the connections between them, all through the terminal. And so all of these commands are going to start with ROS2, right? So this is telling the system, right, that we're executing these ROS2 software tools. And so something that can definitely help early on is that you can use ROS2, the command, and then -help is going to give you some additional information about that command. And there's some commands, and we'll see some examples of this, where you have a command, and then you have kind of a verb, right? So we'll see some examples. So when you get into that more nested command, then it's a -h instead of a -help to get more information about that specific sublevel of the command, right? But what we can do first off is, as I said before, with ROS, we're dealing with packages. And so packages are those collections of nodes which all do some similar function, right? So we have something like OpenCV, where within that package you have image processing, where you can detect lines, do color segmentations, things like that. And so ROS2 PKG, right? So ROS2 tells us that we're doing a ROS command. PKG is that first command, which tells us that we're working with packages. And then executables, in this case, is like that verb that I have in that second part. And then everything that I put in italics, that means something that we're going to replace with an actual name. Right? So if I take, for example, I'm going to open terminal here. Right? So ROS2 package list. Right? So this is where tons and tons of packages that are already installed for you on this virtual machine, right? So that's again where that handy shortcut that we found before, that pipe grep, right? So that can narrow down what it is that we're looking at, right? So TurtleSim, we're going to be utilizing this for lab 2, is a nice little simulator here. Right? It has a little turtle that you can move around, and it's going to get us familiar with some of the key components of ROS. So now I can see that I have the name of that package is TurtleSim. So I can do something like ROS2 package executables, and then I provide the package name, right? So that's why I had package name in italics. And it's going to tell you all of the nodes that you can execute, right? So these are the kinds of ways that we can utilize these commands to figure out something about the packages and the code that we're working with, right? So some things I wanted to put on these key commands for completeness, but we won't talk about them until we start actually building our own packages for some of these. So this one, don't worry about. There's an XML file that tells the packages some key things about relations. So I just included that one here for completeness. RQT graph is something that is useful for visualizing the connection between all of your nodes, right? So especially when you start getting, possibly hundreds of nodes and you want to see how are they communicating to each other, this is a great way to actually visualize that communication architecture, right? So take a look at that when we start working with the TurtleSim and you actually have some nodes that are up and running. So specific to nodes, right? So if we want to actually start a node, right? So we want to say start that turtle simulator. We're going to do a ROS2 run, and then you need to provide both the package name and the name of the node that you want to run, right? So once again, when I have italics, that means that you're going to substitute it in with whatever the actual package name is, whatever the node name is that you're executing. And there are possibilities that there are additional arguments, right? So you don't need to worry about that too much right now, but know that there is a possibility of adding additional arguments, which allow you more versatility. Say if you're doing something like running a node, you can maybe change certain parameters that you have set, or maybe link different nodes in different ways. So a lot of flexibility there. For this initial, what we'll mostly be doing is just running the nodes and interacting with them that way. And if you want to list all of the running nodes, ROS2 node list, right? So you notice how we had before ROS2 package, and then we had commands that give us all the package, so we could list the packages. We can look at specific information about the packages. And we see this similarity running. So now we're looking at nodes. So we have ROS2 node, and then we have these same key verbs, which give us similar performance, but for the specific components that we're interested in. Right? We can also get information to figure out how the nodes are communicating to each other. Right? So if I have, say, all right, so we have ROS2 node list. The node should be running. turtle sim. Let's do return it all. Right. So now we can see that there's a node which is running. Right. So if I wanted information, ROS2 node info, and I can provide the name of that node. And it's going to give me information about how that node is communicating, right? So we can see that there are some subscribers and publishers, right? So that has some communication where it's sending information. There's also some services associated, and there's also some actions associated with this node as well, right? So it's a pretty complex node, but this is a good way for us to get some additional information about the node it is that we're working with. And we can also dig into the specific topics, right? So we can see all of the topics which are available to us that we can communicate with. The -T is going to tell us the type, right? So the type is the format of the message that we're using to communicate on that topic. We can also echo. So echo is going to print whatever is being published to that topic onto our terminal. So this is a great way for you to debug when you're running bits of code to see, are things actually publishing the way that I want them to? And again, you can get information about a specific topic the same way you did about a specific node, right? So a lot of these similar commands popping up. Also good for debugging, you can publish to a topic, right? So if you're trying to debug a certain piece of code, you can use this to publish some data and see how your node is responding. You can also see the rate that things are getting published to that topic, and you can also look for topics that have a certain type of message, right? So as we go through Lab 2, we'll look at how we can utilize some of these and get familiar with working in the terminal to get this information. Right, so lots of different things we can do with topics. There are similar things also with services, right? So once again, you're seeing these same kind of verbs pop up, right? So the command has changed. Now we're looking at service instead of a node or a topic, but the verb there, list, is the same for all of those, right? Similar functions, but we're looking at different components within ROS. And we can also look at the types, right? See what kind of services we're running. We can find ones that are a specific type, right? So maybe if we have 10 turtle sims running and we want to see all of those services, we can use this to filter out and see what those are named. You can also look at the interface type between the different services, right? So how are they actually sending information back and forth through that server? And you can also call services, right? So as we said, it's a little bit different with the topic you're publishing and subscribing. With a service, you're actually sending a call to the server to request them to run whatever code it is and send you a response, right? So that's why instead of a publishing, here we're actually doing a calling for the service. And we have similar things for actions, right? So once again, right, now we're looking at a different component, but we have similar verbs that we can use in our command. So we can also list all of the actions that are available to us. And again, we can get all of the information for those actions. And we can look at the types of actions that we have. And if we actually want to run an action, now the difference is that we're sending a goal, right? So with the publisher subscriber, we're publishing information to a topic or we're subscribing to a topic. When we're using a service, we're sending a call request, right? So we're asking them to do something and then give us that information back. For an action, we have some specific goal that we want to reach. And so we're sending the goal to the action, and we might want to monitor the feedback, right? So we can utilize this additional option, right? So what we would do is we would have this same entire command, and then at the end, we have the -- feedback. And so what's going to happen there is that in your terminal, you're going to see the feedback being published. So if it's something like a robot navigation, it might print to your screen the location of the robot periodically, right? So this is a good way for you to monitor the action to see if it's actually getting towards the goal that you have set, right? So this kind of gives you an overview of all of the commands, right? We'll get into later when we start digging into nodes that there are parameters as well. And you can do similar types of things where you can list all of the parameters. You can get what the values are and you can set those values, right? So this kind of gives you a reference for some of the main commands. You'll also notice that on Piazza, I posted a ROS2 commands kind of cheat sheet. So that gives you an additional reference as well. So what Lab 2 is going to be about is you getting comfortable with actually running some nodes, playing around with these key components to get a feel for it before we actually try to write any of our own nodes, right? So get comfortable with what they're actually doing, what the functionality is before we really dig into how they actually work. Okay. So all of these resources will be posted on Piazza. If you have any questions or concerns, definitely make sure that you reach out. I'm available, the TA is available, the members of your group are available to you, right? So some people might have some background experience in some of this, so they can help you out, maybe explain things in a slightly different way. So if you have any difficulties with any of this, please reach out to us sooner rather than later so we can make sure that everybody feels comfortable before we start moving on to the next topics.